Now we've got the mood set here to bring on our next speaker, Professor Jinhua Zhao, who's a professor of cities and transportation in the Department of Urban Studies and Planning, and also has founded MIT's Mobility Initiative. Please take it away, Jinhua.
Thank you, Elsa, and good afternoon, everybody. Paul started at the scale of the planet, right? I'm kind of shrinking down at the city level now, particularly from the urban transportation perspective. I try to show a few areas that I think AI indeed can help. But I do want to start from a place where I think AI does not, at least not yet, right? You know, throughout, hopefully this moves. Where should I point? Is there a way to? Press this one? Yeah, I did. See, does that, can you help move one slice? No? OK, maybe I'll start with one. It's moving. OK, good. Nice. All right. So throughout human history, we actually invented fantastic technologies that help us move from A to B. MIT has contributed a lot to this, right? Given this pace of development, you will think that our transportation systems must be very effective, equitable, affordable. We should live in paradise, right? If you live in Boston, you know that that's not the case, right? But this is not just true for Boston, right? How many of you have been to China before? Right? So in China, you see this. It's a very similar thing in Beijing, right? But let me ask you, how many of you have been to Beijing in the 1980s or even 90s? Oh, many of you, yeah, indeed. That's interesting, yeah. What you see is this, right? So let's contrast between the two pictures here. What do you see in this picture? Bicycles, pedestrians, public transit. By the way, all electrified, right? How do we call this picture in today's transportation planning jargon? This is, yeah, yeah. This is the low carbon transportation. That's what we talk about, decarbonized urban mobility system. We call this the active travel. We call it healthy travel, sustainable travel, all the beautiful words that we use to describe. This is actually the paradise of transportation planning today, right? Is to look at this multimodal, sustainable pedestrian, bicycles, and public transit, right? But Beijing as a city in the past 30 years strive itself to move from this to this motorized system just everywhere you see in the world, right? So I would say that transportation, urban transportation as a field, we're utterly confused. What is success here, right? I think this is the question I don't think AI can help answer, right? To be fair, we didn't answer that very well, right? These days, I have a 50-year-old son, Duco. He'd be interested in this thing. He asked me, Dad, what does AI want, right? And then he asked, I said, oh, that's such a high, quite deep question. Then he asked, oh, can we let AI want what we want, right? Indeed, that's the alignment question. That's the question computer science community is struggling with, alignment. Is align what we want with what AI want, right? But many of the occasions, I think we as humans, we haven't aligned what we want yet, right? Transportation may be a classic example of this, right? So I want to keep in mind this, what's the limitation of what AI really can do. So with that being said, I would say what's interesting about future mobility, right? I would say is behavior and computation, right? Behavior, what I mean is asking questions like, is travel social? Is travel emotional? Is travel time absolute, right? I wouldn't get into the detail, but that's a different way to look at transportation in the classic way. Typically, we look at congestion, travel time, travel cost. But I try to raise a whole set of other questions that's interesting to understand transportation system. And in fact, many of our business decisions, like electric vehicle range, that's what Tesla asking the question. Ride-sharing pricing, that's Uber asking the question. AV adoption is Waymo asking the question. You can translate all of them into the behavior thinking questions, right? That's one aspect. But the other aspect is the computational aspect. AI has been used in transportation in all different domains. Here is just a few examples of them for a while now, right? Here, let me give you a few examples. So I set up the Mobility Initiative, really try to bring the two together, right? The behavior thinking and the transportation technology. And bring them together, but use the computation as a foundation, right? So here, let me maybe give a few examples. What a fire area? Now we have data, algorithm, computing power, really boosts the performance and the power of computing. But what can it do? I put as representation, prediction, explanation, control, and creation, right? I hope to give some quick examples. One, representation, right? If you look at how do we study cities, at MIT alone, you'll find at least 10 different departments claim study cities. I come from urban studies and planning, so I declare that we study cities, right? We own this, right? But civil engineers say we study cities on this. Anthropology say we study cities. Economists say we have urban economics, right? Sociologists say we have urban sociology. All the different disciplines all study cities. Does this mean that we have an interdisciplinary study of cities? No. The reality is each of us have a different language to describe cities, right? For example, if you are an architect or urban designer, you study city with images, where you draw things, right? And if you're here kind of in the anthropology, urban history, urban sociology, you tell stories. You use natural language to describe cities, right? And here, if you this numerical oriented, you using equations, mathematics, while you use transportation, we're using graphs, etc. It turns out that despite the fact that 10 different departments study cities, we talk across each other. We use entirely different data, different vocabulary, right? Here, I would say this is like the algorithm of the cave, right? Each of us are looking at a particular projection of a city. Here, I would see what AI can potentially do is to bring this together, right? So this is, say, the Chicago, the city, right? You can study this in numerics, population, 2.6 million, there's different transportation networks, different languages, people write stories, different images, but can we put them together, right? Here is kind of stylized possibility here, right? Previously, we want to predict congestion, let's say. Right, so here, sorry, to learn how to. So we put some of these numerics, like your income, your GDP, et cetera, to predict, say, congestion level. But today, with the machine learning, what we can do is we can effectively put images as the input, languages as the input, and the graphs as the input, right? Some of my own students have been working on this area, really try to bring this together, has a multi-channel view of cities. I think that's really a possible future of changing the way we represent cities, therefore all the 10 different departments can really talk to each other, right? So there's with two of my BC students have been working, how do we really put this non-numerical data into transportation models? Previously, we only know how to deal with the relation to the database. But now, you can put images in it, you can put graphs in it, and using this encoder, decoder effectively digest this data, right? So that's point one. Number two, you can use computer vision to do predictions, right? Say bus number one, I don't know how many use it, they often delay. By introducing computer vision, you can enhance the prediction accuracy significantly, right? Another example, in this natural language, this is from Washington, D.C., for their WMATA, their transit, public transit system. A lot of discussions about it. Previously, we don't know how to deal with those things, right? But now you can encode this very effectively by digesting the natural language here, right? Then lastly, maybe let me give another example. This is a project with Department of Energy, try to use machine learning to improve the public transit operation. Here, give a particular example. Many of you maybe encounter this bus bunching, right? Bus don't come, but when they come 3 in a row, right? So what we've been using is using this, this is in Chicago bus Route 81. We've been using this control tool to improve the space out of the buses, to improve the system. There, we have this human-in-the-loop strategy. We have RL as a base engine, then where you have a human judgment, and combine them to implement this intervention. What we achieved is, if you pay attention to here, this is before our intervention. This is average waiting time, and this is during the pilot with our intervention. So we're able to reduce the average access waiting time by 30% without adding a bus or adding a bus driver, just through the control strategy. So there's a lot of power coming out of this, right? So lastly, maybe I'll give an example of the generative planning. You know, planners, we do models, we send buses, etc. But another very important thing is we engage with the public, right? I'll give you an example of this process, right? Often, so here, there's some views about zoning policy, et cetera. Then there's the urban planner here talking to the public, saying, get them the ideas, right? And then we generate a map of this, right? But let me describe one problem. See, suppose I'm the planner giving a presentation. Some of you stand up saying, oh, I want a bicycle lane in front of this neighborhood, right? I would say, oh, that's a great idea. come back in 3 months because I had to go back, do my model, do the painting, and then come back to you. 3 months later, you forgot about what you talk about, right? All the momentum are lost, right? So what AI can do is really expedite this process. So give you an example. This one by Qingyi saying, here's the have a city, satellite image of a city, Chicago, this land use description, et cetera. So show me a possible layout. With AI, I mean, that the Qingyi developed, then you can instantly generate one, right? But then you say, oh, by the way, there's a river coming by, add a river to it. Then you have a river to it, and instantly you can generate those things. And then you say, oh, there's a railway, consider that. You can put a railway, and then here's the major road, you put a major road. So that gives instant response, right? That really changes the planning engagement process there. Right? So those are the 5 things that you can potentially use. There's a lot more to be explored. But let me emphasize one last thing. There are 2 different roles of models in planning. The first one is literally do the prediction, do the calculation, and run things. But the second one is to communicate the model to the public and to the decision makers. Right? You'll find the power of the complex model. One downside is that the more complex, the less likely you're able to explain it to the public in any meaningful language. Right? So you'll imagine the public engagement going this. So here's the model, here's the result. People ask you, what do you do that? All I can say is, trust me, the model says so. Right? This destroyed the whole notion of this communicative planning as an important function on this, right? So last as a conclusion, for those functions, I think we have a lot of potential to do, right? For communication, we really be careful on this, right? This danger of losing the possibility of communicate. From the other side, you have a large language model become the interface where the planner can engage the public in a very meaningful way. So it's a mix. It has the potential to have a downside. But in terms of the first question I raised, what is success? That will never be done by AI, and that needs us to really think hard and come to what do we desire as the future of cities. Thank you.
How relevant it is to understand the motivations that shifted one society towards, a certain form of transportation in this type of research?
Yeah, I mean, in terms of the transportation technology, right? Let me give you this way. I'll use a bicycle example, right? Bicycle, when it was entered into China, that's like 150 years ago, it was seen as the symbol for modernity, right? If you ride a bicycle, you represent the latest technology. In fact, people use it as a symbol for woman liberation. You ride a bike, so you have the freedom, right? Then later it moves on, and for a while, China became the kingdom of bicycle. Everybody have a bicycle. Then there was a very sad stage where riding a bicycle would be seen as a failure of life, right? Only the poor, the student, the delivery person use bicycles. There were very sad situation there. But later, then it recovered, right? Now, bicycle was regaining is kind of a cool picture. Like, I'm an active person, so I use a bicycle, right? Indeed, there's a lot of, that's what I emphasize, this behavior aspect of transportation, how that mobility culture impact the system there.
You maybe have your mic on.
I love the idea that you can train a model on all these diverse kinds of data, including the images and everything. And I wonder if you can just suggest some of the things that such a model might be used to predict. Or
right, yeah, that's what we've been trying a little bit, right? Previously, for example, in order to do this predicting the traffic, et cetera, all we can do is you have a numerical data, right? A number of cars, number of roads, all these things, right? But now you can say, take a satellite image, right? We have the building environment, and feed the image directly into the model, right? Now the model is able to digest the image into something like in this latent space and merge that with the numerical data into prediction. We show that you can improve the prediction accuracy quite a bit, right? So there are a lot more in this satellite image that can capture information that traditional human engineered method cannot capture in this. Right?
Maybe I can ask one.
Oh, sure, please.
I was trying to understand that I find one of the big problems in applying AI is always to have relevant data to inform, for example, planning of a city. So you already gave an example of response to using bicycles that change with societal change. So how do you deal with the fact that when there is a transition to a new city plans, probably the response to the population will be different from what it is today, and you don't have new data for the future?
On that, I would say two things. So from one side, there's really a positive side that AI is able to deal with also previous information, but we don't see as meaningful data. So for example, some historian write a book about Boston, right? As a city planners, we cannot engage this book. There's a lot of knowledge in this, but we cannot codify it, right? But now potentially you can digest in the book, read the book, and become meaningful knowledge on this. So that's one side. But the other side is there are a lot of social phenomena that we do not collect data on, right? Well, if we build up a model only upon the data we have, then we're missing a lot of part we don't, right? My colleague Catherine Ignazio write a book called Data Feminism. One part is to argue that there's many part of social phenomena we don't have data for, right? We need to proactively collect data and build upon the model rather than just search for whatever data I build a model upon.
Thank you. So we can move to